Gentlemen, welcome back. It's been a hot moment since I've sat down and been able to throw a video out for you all to watch. So we're going to get ourselves right on task here immediately. This is a Davemade, don't know what. Mr. K sends this up for repairs. He states to me in his notes, okay, this came from a gentleman in California, a repair shop. Name will be omitted to protect the innocent. Or the guilty, however this may turn out. This came from, last looked at it, he said the Toshibas installed are no longer available, so he couldn't complete repair. The notes that he sends with it were very thorough, by the way. Davemade amp, no output, when turned on, no symptoms other than meter showed no output. 2SC 2879s, matched pair, Toshiba transistors. And then let me scroll through this. There's one other thing I wanted to talk about. Yes, Chris over at BM Technologies has officially been designated by Dave himself. Ding! Knighted by Dave himself. And this isn't even a Davemade. We'll get into that in a second. Got knighted by Dave out of New Jersey to carry the lineage forward with the 2879 and development of many different things. Chris is a good personal friend. He's a great guy. Don't care what anybody else has to say about him. Everything I've ever done with him has been good. The only problem with Chris is you can't get him to answer the damn phone. Poke, poke, rib, rib, buddy, because I know you watch every one of my videos. Love, nothing but love and respect for you, man. This is a hard game that we're in. Believe me, I understand. So, this is actually built by Joe. Davemade Moby. The gold gives it away, per se. Even though Dave did build with the gold, we'll know as soon as we open it up what's in here for parts. So, we're going to utilize this view, and let's switch over to the other camera. This is going to be our top-down view. And the reason we're having to do this, switch back to the big camera, is this thing is so big. So let's get back up to the big camera, overhead, the eye in the sky. And let's pop this open and see what we got going on. I don't want to just hook it up though. It sounds like the other CD shop, or whoever worked on this last, name being omitted, of course, because we are somewhat professionals here, unless you really get underneath my skin and decide that you're going to try and poop a baby in my mouth. I try to stay above most of the politics. And nothing against Joe. Nothing. I got nothing to say. All my experiences with him have been interesting. Oh, this is definitely a Joe Bill box. Why? Because it has an electronic product design transformer in it. It's got these old schmooey garbage rectifiers in here. Our output combiner resistor in this corner is smoked. Our voltage divider from the driver is smoked. Variable still feels okay. We have a burnt, looks like two burnt transistors here, one here. Now this is on a fixed. We'll zoom in, we'll see if we can get this to, hopefully it won't make you guys motion sick. Here we go. We'll make this happen, Captain. How do I move that? There we go. It's looking like we got two burnt transistors. For perspective's sake, one is here and the other one is here. We know that because the magic 10 ohm smoke has been officially released into the outer atmosphere, polluting the universe 1 and 10 ohm smoke resistor at a time. The thing I take issue with is this right here. That is definitely a Joe thing. It's okay. We're going to upgrade it. So this is a big giant cavernous box, for the lack of a better term. It's huge, right? Let's switch back over to the big camera. So we got two 120 millimeter fans blowing air in. And the only way the heat sink's going to cool itself, let's go back to the overhead camera, is through magic, lies, and pixie dust. What do you mean, baby? I own one of these and it's run great for decades. Great! Glad it has. It's awesome sauce. You haven't run it very hard. You've been nice to the equipment and you're not sitting there playing musical dead keys for 4 hours. What I'm talking about is this vent slot that runs the whole length of the cabinet. Now, there is, for a lack of a better term, beauty in the Lego design. We can take this cabinet, and I say we as in us builders, and we can do about 100,000 different things with it if we stick with one size cabinet and we're not overly concerned about footprint size. So let's go back to the other camera. This one here. We could literally make this cabinet this tall and eliminate all of this space, and then we could make it about that wide. So we've got all this extra volume in the cabinet that we're not doing anything with. But we can take this same enclosure and we can put multiple transformers in it. We can put like 10 pill in here. We could do a bunch of different stuff with this size of a cube. So if you embrace the idea that you're going to buy 100 of these cabinets and you can make them into a 2 pill, a 4 pill, a 2x4, like this configuration, a 1x4, you could turn this into a 6 pill, an 8 pill, a 10 pill, with the power supplies in it. One cabinet rules it all. And when you break these down, because the sides aren't fixed, you've just got a stack of metal about that high. So you can have 80 of these on the cabinet, on the shelf, where if you had them assembled, okay, does that make sense? You guys got the visualization? The other thing I want to point out is this does not have sideband. We have a squidge. We do. No sideband. That means we have a delay on the relay. I don't know why we ever got into this. I don't know. We have a fan high-low, which apparently is just a couple resistors all clumped together down in there. And this does concern me greatly. This is our positive power wire. Or no. This goes to our LED. Let's go back to the lid. Let's go back to the top view here. We have a voltage regulator right here. And somehow the magic shmoo in that voltage regulator is supposed to run both of these. Well, that ain't too bad. 3.2 amp fans and the LED, but we've got it on a flexible joint that we can all see is clearly not heat shrunk or anything. So that can bang up against the cabinet, causing your fans to quit, killing your voltage regulator, and on and on and on. So we know we got a couple dead pills. I got to call the customer at this point. It is one 2879 Toshiba driving 4 2879 Toshibas, and see if he wants to take on the cost of nearly $400 for the 2 transistors, or if he just wants to put HGs in them. The HGs are a viable option. No, we don't want to make this into a 2879C box. Not with that big of a driver. That we'd have to completely rebuild the amplifier, so it'd add even more cost to an already very awkward situation. I have the transistors in stock. That's not a big deal to make this run with Toshibas. In my opinion, the Toshiba is still slightly a better component. The 2879C does put out more power, but it requires a complete rework of the amplifier, or we could just put 2879 16D 08 transistors in the holes and move on. I have a feeling that when we go and we test this output cap back here in the corner by the relay, we'll find that its capacitance is low. This is an older built box. We know this because of the metal clads that are on top of the output transformers. Tony over at ICA was kind enough to step forward and put the money up so that all of us aren't starving to death for our components, and fronted up the money to get the capacitors coming, and he's got them in stock at the moment, but he sells through them fairly quickly. So what I'm looking at here, what I see with my ability to visually understand what's taking place with my eye holes, is one, we need to check our electrolytic over here in the corner. And I didn't realize this was so delicately put together. So now I got to be very ginger at this. And I got to disconnect the high-low for the fan and disconnect this wire and quietly pray that we haven't overstressed those legs. We're going to pray. We'll replace, and back on topic, sorry, got sidetracked there. Check our electrolytics. We're going to replace these shmooey rectifiers. We'll probably put one of these little beauties in there. Old reliable. Our 200 amp, 1600 volts, supposedly straight from Chinesium, but solid as a rock. Embedded rectifier breaks, which work amazing. We need to plug up the vent holes in the back so we can have a little bit of directional control of the air, so the air is not just coming in and running out the back. It's going to actually have to be forced to go down the heat sink and help dissipate heat. See, heat sink's great, but unless we push air across it to make the magical pixies, the heat pixies, because that's what that is. Heat is energy, right? Make the magical heat pixies get absorbed into the air and give us the ability to dissipate that energy into the atmosphere, this thing will sit here and cook itself to death. And I'm going to leave you with this parting thought, and then I'm going to run away and I'm going to call Mr. K here. Let me zoom in here for a second. I want to show you these transistors. As we look around the transistor, specifically around the edge of the ground tabs on the transistor, emitter legs, you'll see the legs are all black, and you'll see there's bubbled out flux. What causes that is tremendous amount of heat. Remember, flux is designed to dissolve at a lower temperature than the actual solder and tin, the lead and tin that makes up solder. So when the circuitry starts to get to be a couple hundred degrees, the flux will cook up to the top of the solder. It'll pass through the solder and float up, and it'll start to break down. But it doesn't get quite hot enough to turn itself to a gas, smoke. So it discolors greatly. It's a very big indicator that the amplifier has been really hot in its operation in its life. And it's not really from probably abuse. It's more from a lack of cooling, in my humble opinion. Now these things are a booger to work on, once again, because the box is so big, but what I have found, and you'll see we have heating issues over here on the driver transistor as well. This has been hot, and this has obviously been repilled once or twice. Maybe once. I know the driver has definitely been replaced at least once. And we got a variable on the front. So, at the end of the day, I got to call Mr. K and find out what he wants to do. I found it's much easier to work on these things if I fully remove the lid, and then I just disconnect one of the sides or take the back off. That way I can get my big girthy finger sausages in the holes. Okay, we shall return. Bye, 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 bye. Okay, so we're back. Now, over here, this is where our transistors are going to end up. Up here, we're going to video me taking the transistors out. So let me grab 2 meters. That is my identifying tool. Let's grab this one here. This will be my capacitor measurer. All right, I'm fully prepared for this. See, I got like 12% on one camera and 10% on another, so we're gonna run here pretty quick. Let's get this first transistor out. I went ahead and I saved you guys having to watch me peel these things out of here. to where I just had one tab hooked up. Let's get these things out of here real quick. Come on. Come. I know you're bad, so I know you're going to fight me all the way. That's one. Two. Come on, let me have it. It's two. Jeez. These things are so covered in heat sink compound, it looks like a TO1 on hooker after working a Friday night on spring break. Sheesh. Okay. So, let's go back over to the big camera. There's our transistors, and hopefully we can get this done before the camera dies, because the camera I'm down to 8, and the other one I'm down to less than that. So, let's get our transistor checker out. This is the order they came out. This is the one closest to the edge of the cabinet, the next one in, the next one from that, and then the last one. So, forward and reverse. Let's see what we get. Survey says. This has got a gain of 38 on it. That's good. It means it's really strong. Here is the one that we know for sure is blown, but we're going to test it anyhow. Because I've had guys repill stuff and not bother to change the 10 ohm smoke indicators. Don't matter, the lid's lifted off of this one. Yep, it's junk. Okay, and I think this is our next one. That was shorted. Ugh. Gain of 37, sweet. So I compare these two together. Okay, gain, focus, 37. All right, that's good. That's good. That's good. So these are junk. I'm gonna throw those away. Slide those to the side. Dude, that's awesome. That saves you 400 bucks. That's freaking great. Okay, so let's go over here. Sorry for doing that live, but we're running out of time. Last thing I want to check is our low voltage filter cap on our unregulated supply here. If you notice, the cabinet's a little bit more bare than what it was. Rectifiers are out, all that thermal compound is cleaned out of here. Transistors are out, all the burned up parts, power wires are all removed. Ground lug over there at the base of the transformer has been removed. All right. It's a little low. And circuit leaky. It's no good. So let's see what we can figure out for a filter cap for you. Yay. So what were you just saying, Nate? It puts the shmoo on its skin where it gets the hose again?
Right.
All right. Just over here working away. Got the new bridge rectifier installed. All the new power wires installed. So I took that same capacitance tester that we did the testing on this thing, and it said it was low and leaking, and proceeded to check like literally 100 more caps with it, it seemed like yesterday. And anything below about 100 volts, it was telling me it was low and leaking, and come to find out the battery was going low. So I have a feeling, a sneaking feeling, that cap is actually good. And it looks remarkably like this Mallory cap that I have here, this nice Made in America cap that I have here that is good, I know is good. So we're going to go ahead and we're going to run this as it sits for the time being with this cap. We'll come back and we'll see if it's got any AC hum to it in operation. And if it does, we'll just change this cap out because I've obviously got a replacement new one. So power wires are in. Then over here, let's draw our attention to the back of the cabinet over here. Our new air directional blocking system is now installed. So now most of the air has to go, instead of running right out the back of the cabinet, actually has to go across the heatsink and get squirted out the back hole. Not the front hole, that's where the pee comes out, not the back hole. That's where the hotted air comes from. So we'll give the opportunity for the electrical pixies to pick up heat. Went in here and cleaned out all the pill pockets. Those are all clean. So now it's time for us to go put new transistors in. And then the other thing I wanted to show you guys, as I was talking about this in the previous segments, was this capacitor. I tested it. It's just fine, so we're going to reuse it as well. And I replaced our relay. I got rid of the little blue, we were just having this conversation, and I had this conversation with another builder, and he couldn't understand why I kept saying to him, on a 4-pill, you can't use this style of relay. And he goes, well, it says 5 amps on the side. That's more than plenty. Right. So what happens, Nate? This rating is 5 amps at 240 volts at 60 hertz. Right?
Yep.
Okay, so what is the international CB frequency? It's 27 whatever, right? So roughly half of this rated value in frequency. So that means we have to reduce the amp qualifications for this relay to what? Half. So this is only a 2 amp relay. It's been working for a long time. But I know my luck, and I know how things work over here. If I was to turn this thing loose and say, you're good to go, within a week, he'd be calling me up saying the relay's kaput. So we just went ahead and we put an actual 10 amp relay in there, which is a true 5 amps at 27 megahertz with RF operation. So we'll run with that, and that's what we're going to brag to the girls at camp about. So let me grab up a couple more transistors. We replaced our 10 ohmers that magically let the smoke out. And we'll get the transistors in. We'll finish up with our power wire upgrades to here. We'll get our capacitor put back in, and then we'll tie this back into the new relay. And we'll give her a shot. So away we go. Look at this. That's 1,000 watt in peak, 1,000 in average, and a 5 watt slug in reverse. So now, let's scoot this up real close. And what we got going on here is we got all the transistors in. I gotta scoot this over yet. There's a bunch of little stuff that's broken, but it's enough that we can test it. So here we are in DC volts. And this is what I was afraid of. My meter gave me false information. So we're looking at 20 volts floating. Let's go look at AC. If there's any AC ripple there, I don't see it. It's not a measurable number at 1.001 or 000. So now, let's go take our little selves and look at our spectrum analyzer.
Yes, master.
0 through 500 megahertz, we are reading from 0 to negative what? 50? Yeah. So check this out. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Now, we'll come over here to the oscilloscope. There's nothing there. It's as quiet as could be. Quiet as a church mouse. Hello, 1 2. Hello, 1 2 1 2 1 2. Hello. Kind of flat topping. A little bit of over modulation. But now let's go look at our watt meter. Remember, 1,000 watt, 1,000 average, 5 watt slug in reverse. Focus, focus. Hello, goodbye. Hello, goodbye. Okay, so now we're going to take it to the 2x position. So right here is 1,000 watts, 12, 14, 16. Okay. Hello. 1400 peak. But remember, that's with little to no drive. Incredibly low drive box. Turn the amp off. Hello, 1 2. That's with 10 watts of drive. So the question then remains, what happens when we... I'll turn the voltage up here in a minute. What happens when we run the voltage up? We'll find out here in a minute. Let's back this out a little bit. Too much stuff going on here. So first things first, last things last. I have to fix this. This is no bueno. No good. I'll fix this. We're going to shorten this silliness up. And then the switch right next to it, which is the operate standby switch. Well, there it is. Broken. So you gotta fix that too. Over here in the back of the cabinet, no gramito. No grommet. Have to have a grommet. Now it kind of had the remnants of one when it came in here, but it was so disintegrated in the process of working with it, the grommet has just fell apart. So put a new grommet in it, fix the high-low switch, fix this, fix that, and then we'll do our final test. But needless to say, filtering cap, good to go. Well, here we are at the very end of this tale, the end of this song, this saga, and this dance. So, got all the little stuff taken care of. The grommet over here is done. Got all the solder work on here redone that I wanted to do. Power upgrades done that I wanted to do. Rectifier block repaired. Got all the little burnt bits and pieces out of here. Repaired the standby operate switch. It's got a brand new switch down in there. Fan high-low switch. Everything's working. So now, that sounds annoying as frig, doesn't it? But we slam the lid on it. We find a scroob. One scroob. That's all this is going to take. Scrooby-doob. Okay. Let's come over here. Let's take ourselves a look for... Sorry about the odd camera angle. It's moving air. Like, it's seriously moving air. But the reason we're really at this odd camera angle is this is our ICOM. We're going to be using that to receive us. And let's take a look at our meter. Now let me take and we're going to flip the switch on this thing here real quick. We're going to go down to 1X. Okay. Hello, 1 2. Off the scale. Let's go up to 2X. Hello, 1 2. Hello, come in. Hello, 1 2. It's really important that I show that this thing has got Hello, 1, 2, 1, 2. Really good sound to it. I can tell you without a shadow of a doubt that that electrolytic is great. So now, let's go look at something else. Take a look at the icon. Hello, 1, 2, 1, 2, 1, 2 audio. No hum, no buzz, no nothing. Now, let's go look at our input reflag. Hello, 1, 2, 1, 2, 1, 2. That's it, that's all she does. Hello, audio, 1, 2. Hello, audio, 1, 2. Hello, 1, 2. Hello, hello. Because of that high volt transformer that's in this thing, it is screaming. But at the end of the day, let's turn on our brand new FLIR. This is the FLIR E6. Nothing too special about it. Let's see, it is showing us that we've got 84-degree air coming out, and our ambient air is 75. This thing is moving air through it now. Now everything's cooling the way it should. It's done and done. Davemade. Davemade. And guys, please forgive me if I didn't get the history of old Davemade and Joe and Chris and the other Chris and then the other guy named Steve and Kevin and friggin' all the other people that were involved with Davemade right. Just giving a brief, short synopsis. I wasn't there. I can only go off of what other people have told me. But it's got this voltmeter on here. It's reading very accurately with what it does. And remember, this has nothing to do with variable volts. This is variable radio power. And all that does is by turning this knob up and down, increases or decreases the amount of signal that comes from your drive radio. So like I said, I'm sorry if I didn't get the history, the lineage just right, or somebody out there is cracking, oh, haha, he doesn't know. You're right, I don't know. I'm in Idaho. I wasn't there when it happened. And someday I'll sit down with Dave himself and ask him that question. But until that day comes, it's the story that I'm spreading to the masses. And believe me, when I say to the masses, a large chunk of the radio community tunes in to see what I got to say about things from time to time. Just saying. Well, my friends, our time here together has come to an end. My time with this little 1x4 is finished, and it is electrically correct and will run right and purposely for now until the end of time. No, it won't. I have faith in my fellow CBers that this will get used, run hard, put away wet, but it's as close to right as I can make it here today. As I say in every video, if this is your first time watching, welcome. Take a minute, please subscribe. If you are a repeat offender, I say welcome back and thank you. Big shout out to Siglant, big shout out to Excess Power. Big thanks to Bird & Coaxial Dynamics. And remember, the biggest and most important shout out is to every single one of you guys. Appreciate you. I'll see you. Bye.